Hey guys, Miss Watson here. Hope you had a great weekend. We are starting here today with some review of the worksheet for 11.4 on conditional probability. So, thank you to the 15 people who went ahead and filled this out for me. I hope these videos are helpful for you guys. Okay, so just scrolling through these, I do recognize that conditional probability can get a little more confusing. Um, so number 5, I think, was a tree diagram. So I'm going to go over that. And then I think what I'm going to do is just go over 7 through 12. They all related to the same question. Um, and you can see here they're pretty similar responses for 9 through 12, which were all the condition ones. Okay, and then we have our questions down here. All right, so let's go ahead and get to it. Give me a second. There we go. Move this. Okay. So conditional probability, again, is a probability of event B happening given that event A has already happened. Now, for these first ones, usually we're okay because the tables are usually pretty straightforward to get through. Okay, just remember with the tables that the condition is the bottom number. So in number 2, it says has no diploma, given has experience. So the denominator would be the total number of people with experience, and the numerator would be um, of those people, how many of them do not have their diploma. All right, number 1 is just an and statement, so diploma and experience. So you just look at the chart here, right? How many of them have their diploma? Well, it's 54 and 27, but of those, how many have experience? Well, it's 54, so you do 54 over the total. Okay, so I'm just going to do that because I think someone later on asked about that one. So number 1 would just be 54 over 90, which reduces the 3 over 5, right? And the 90 is the total of everything in the chart. Okay, let's go down to number 5. So here's our tree diagram. So what you need to do when you do a tree diagram is figure out what are your first 2 branches, right? Basically, so it says here that there's a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. So what do you have to know first in order to find out if they're going to win? You have to know if it's snowing or not. Okay, so um, I always do this, and I'm going to start with this is going to be snow, and this is going to be no snow. Okay, because again, our question is probability that the team will win. Well, that is based on whether or not it snows. So that's going to be our opener. And then if it snows, there's 2 possibilities. They win or they lose. And if it doesn't snow, there's again 2 possibilities. They win or they lose. Okay, and then you just kind of fill it in here. So it says a couple things. Let's break this down. What's the percent chance of snow? 50% chance of snow. So this is 0.5, which means the chance of no snow is also 0.5. And then 70% chance of winning when it doesn't snow, 40% chance of winning when it does snow. So doesn't snow, chance of winning is 70%. So this is our 0.7. Chance of winning when it does snow, 40%. Okay, and then you got to fill in the lose, right, or the not win, and that's just going to be 100 minus, or 1 minus 0.4. So this one's going to be 0.6, and this one's going to be 0.3. Okay, and now the question says, find the probability the team will win. So to win, well, there's 2 options, right? They could win on this path, or they could win on this path. So you have to take into account both. So it's the probability of winning given it snowed, plus the probability of winning given it didn't snow, right? Because they can win if it snows, or they can win if it doesn't snow. So fill these in. All right, winning given it snows is going to be 0.5 times 0.4. And then winning and snowing. So not snowing is going to be 0.5, 0.7. And work this out. You're going to get 0.2 plus 0.35. So you get 0.55 or 55%. Okay. All right. Now let's go to the tree diagram that's already created for us. All right. Most of you guys got 7 and 8 correct, but let me just show how you would do this. So probability that it's closed. So the school is closed. So there's two ways, kind of like what we just did with the winning, right? It can go this way and it also can go that way. So this is going to be 0.4 times 0.8, or it could also be closed 0.6 times 0.3. Okay, work that out. You should get 0.5 or 50%. Okay, now I do recognize that some of you guys may have guessed 50 and saw that on the answer key and thought, oh yeah, I did it right. But this is actually the way to do it. Okay, it's not just that it's always just going to be 50%. Okay, the next one is probability that it's heavy snowfall and schools are open. So let's look at that. So this is going to be heavy and open. So this is 0.4 times 0.2, and we get 0.08 or 8%. Okay. All right. Now the conditions. So first thing is I'm just going to write the formula up here that I'm going to use. And this was included as part of the notes. Again, when it's a table, it's much easier to do the conditional probability. With the tree diagrams, it could be a little tougher. All right. So the way we look at conditional probability. So the probability that B given A is going to be the probability of A and B divided by the probability of A. And this can also be written is that the probability of A and B, if you just rewrite this, is equal to the probability of A times the probability of B given A. Okay, now I'm going to use this first one right here, but I just wanted to show you that it works both ways because it's just a different way of rewriting it. I'm sorry, I'm going to use this entire thing. Okay, so let's look at number 9 here. It says, what's the probability of heavy snowfall given the school is closed? Okay, so again, you read that as what's the probability of heavy snowfall given the school is closed? Well, we already know, so this is, sorry, let me write this. Going to be equal to the probability of using this formula, closed and heavy, divided by probability of, probability of closed. Okay, and I'm using this formula up here. Okay, well, we already know this is 50% because we got that right there. Okay, so don't forget that part. So probability of closed and heavy. So closed and heavy is right here. So this is going to be 0.4 times 0.8 divided by probability of closed, which is 50%. So 0.5. And oops, I did that wrong. We get 0.64 or 64%, and I'm just plugging that into my calculator. Okay, so let's follow that same pattern for the next one. So again, using the formula, probability of light snowfall given open is going to be the probability of open and light divided by the probability of open. Well, here's the deal. This must be what, guys? If the probability of the school being closed is 50%, the only other option is that it's open. So that means this must be 50%. Okay, now it didn't specifically ask you to calculate it that, but you're supposed to use deductive reasoning there. Okay, so now we're looking at open and light snowfall. So light and open. So this is going to be 0.6 times 0.7 divided by 0.5. And we get 0.84 or 84%. Okay, let's keep following this. Probability of light given closed. So probability of closed and light over probability of closed. Again, this is 50%. We know that because we calculated it in number 7. So hopefully you're seeing the pattern here. Closed and light, light closed. So 0.6 times 0.3 divided by 0.5. You should get 0.36 or 36%. Okay. And then you should use the same, let me just do it for you since I'm doing these. For the last one, probability of heavy given open. So it's probability of open and heavy over the probability of open. And again, this is 50%. Now, remember, that's just not, oh, it's always going to be 50%. That's because we calculated in number 7 that the probability of closed is 50%. And the only other option besides closed is open. So they must equal 100. So that's where that 50% comes from. Okay, last one here. We're looking at open and heavy. So heavy and open. 0.4 and 0.2 over 0.5. Work that out and you get 0.16 or 16%. Okay. Hopefully that helps you guys now. I know those were pretty tricky. Okay, so I fully recognize that. Okay. I don't really understand which numbers to plug into which variables in the formula. So if you're talking about just what I wrote up top here, just remember you read it as probability of event B given event A. Okay, the condition is always going to be the bottom number. The condition is what we call A in this. Okay, 9, 10, 11, 12. This is exactly what I'm talking about. It seems basic, but that's why it gets confusing because you think, well, what am I missing here? All right, 9 through 12 we did. 1, I went over it briefly. 5 was our tree diagram, 9 and 10, and then I did 1 tree diagram. All right, guys, I hope that was helpful. You're going to get more practice today on conditional probability, but please don't hesitate to reach out if you have more questions. Thanks.